Alright, so welcome back to Mr. Yasuda's math videos. This video is going to be about building and using what we call in trigonometry the unit circle. And so first off, what is the unit circle? And so the unit circle is just this, diagram, if you will. It's this diagram that allows us to kind of collect all our information that we've been studying. So things like reference angles, right? So things that you've learned, like reference angles, those go in the unit circle. Sine and cosine are in the unit circle. And we actually can find, and then also the values of sine, cosine, and tangent, right? In regards to quadrants, right? Those also are going to go in the unit circle. So I've got videos on reference angles. If you're not sure what a video or what a reference angle is, go check it out. If you're not sure how to evaluate things like sine and cosine with a reference angle, and you haven't memorized those kinds of things, go check out my videos. Also on quadrants, feel free. But nonetheless, let's see, how could I maybe give you a little diagram of what the unit circle is. So here is the coordinate plane, our x and y axis, and let's say that we've got a circle here. That's not terrible, guys, that's pretty good. So let's say that we've got a circle here, and let's say that the radius of the circle, the radius is 1. So what would that make this point? That point there would be 1, 0. This point here would be 0, 1. This point here would be -1, 0. And this point here would be 0, -1. And then on the unit circle, here's what happens is this collection. We have these angles that hit these other points on the unit circle, and those points help us evaluate the sine, cosine, and tangent in there, and it's just a way to memorize. So what you're going to end up seeing by the end of this video is you're going to end up seeing how to create the unit circle to build it, and there's 3 points in every quadrant, and so here, right there, so there's 3 points in every quadrant, and I'm going to teach you how to build that so that then you can use it to maybe help you answer, how to evaluate a trig function like cosine of 3 pi fourths, So the unit circle will direct your attention to the answer of that rather quickly. So if you can kind of get familiar with the unit circle, your evaluating of specific trig functions with the appropriate reference angle will go quicker. So let's talk about this unit circle. Let's build the first quadrant together. So I'm going to draw my coordinate plane a little bit differently this time. So I'm going to draw it like this so you can see it. So I'm going to work in the first quadrant, and in the first quadrant are the following angles, okay? So I better draw my quarter of a circle here. So there's the point 0, 1, right? And there's the point 1, 0. Let's get those in there, because remember the radius of the unit circle, the radius of the unit circle is 1. So 0, 1. Alright, so like I said, there's 3 points in the unit circle. So starting from the center, I'm going to draw a line that way. And we're going to call that 30 degrees. Or, if you know your radians, it's pi 6. Okay? Then the next angle is 45 degrees. Or pi fourths in radians. And then the last one is 60 degrees, or pi thirds. Okay, and so those are your angles that are in the first quadrant. And these are going to actually be the reference angles that we use for the rest of the quadrants. Okay, and so now the way the unit circle works is that the following point, okay, this point right here on the unit circle, if you could see that in blue, that point, okay, is going to be made up of, and I'm going to write it over here, the points on the unit circle go as follows. They are cosine of theta, comma, sine of theta. Okay, so what does that mean? Take, for example, 0 degrees. Sorry, I didn't write that in over here, but this first flat line would be 0 degrees or 0 radians. So if you were to do the cosine of 0, right? Cosine of 0 degrees or 0 radians, the x value on the unit circle would tell you what that answer is. So the cosine of 0 equals 1 because the x value is 1. And then the sine of 0 is 0 because if you look at the unit circle, right, the y value is 0 at 0 degrees. So that's kind of the idea of the unit circle. So how would you get the point for 30 degrees? Well, we could just tell ourselves what's the cosine of 30 degrees. And if you're in my class, you better have it memorized, hopefully by now. So cosine of 30 degrees is radical 3 over 2. If you're not sure how to get it, you could always draw a 30, 60, 90 triangle, right? There's your 30 degrees, 60 degrees, and you could say 1 rad 3 and 2, and then you could do the cosine of 30, which is rad 3 over 2, and then the sine of 30 degrees is 1/2. So the point on the unit circle at 30 degrees, or pi 6 radians, is rad 3 over 2, comma 1/2. At 45 degrees, you can either just have memorized cosine of 45 degrees, or you can draw yourself a 45, 45, 90 triangle, right? And that's 1, 1 square root of 2. And so the cosine of 45 degrees is rad 2 over 2. And the sine of 45 degrees is rad 2 over 2. Okay? And 60 degrees is pretty easy to get, right? So there's 45, here's 60, because the cosine of 60 degrees is 1/2, and the sine is rad 3 over 2. And if you take a look, that point is just kind of the 30 degree point flipped. And so there's your first quadrant. So if somebody is trying to use the unit circle, right, they could say and look at this first quadrant, and if somebody asks them what's the sine of 60 degrees, all they have to do is look at the y value, right, and they could say the sine of 60 degrees is rad 3 over 2. So it's this nice way to collect all the information that you learned in a trig class and put it into one diagram, and it just helps you kind of keep everything, I guess, collected and organized. So shouldn't be bad. So if I were to ask you what is the sine of 90 degrees, hopefully you are looking over here, 90 degrees, and then you're going to go to the y value, which is 1. So the sine of 90 degrees is 1. Now if that's the first quadrant, right, if that's the first quadrant, why is that one crucial? Well, the first quadrant actually can help you build the other three just by reflecting those lines into the other quadrant, okay? So rapid fire, if you want, you can hit pause, all right, and try to build the first quadrant on your own and see if you've kind of got it down. But I'm going to draw the first quadrant. Give me a second. All right, so I've drawn first quadrant, but I've also drawn all the other ones. And so let's label those angles real quick, right? So this is 0 radians or 0 degrees. This is 30 degrees or pi 6, okay? This is 45 or pi 4ths. And this is 60 degrees or pi 6. So what I'm going to do is let's just start with the second quadrant, right? So the second quadrant is over here. And as I said up above, there are 3 points in every quadrant. And each of the angles in that quadrant either have a reference angle of 30 degrees 45 degrees or 60 degrees. So if I start with this one closest, right, this guy that I'm kind of highlighting here, if I start with this one closest to the x-axis, what would you say its reference angle is? Well, it's the same as this guy, right? And so since it's the same, then that's 30 degrees away from, let's think about this. This is 180 degrees, or pi, right? So it's 30 degrees away from that, so that would be 150 degrees. Or in radians, if you want to convert it, that's 5 pi 6. So let's think about this. What's the point here? Okay, if it's just this point over here reflected over, now you're in the second quadrant where the x value is negative, so it's negative rad 3 over 2, but the y value is still positive, so 1/2. Okay, the next one's 45 degrees away from 180, so that would be 135. Or in radians, it's 3 pi 4ths. And then think about what the point would be. It would just be this point, but an x value being negative. So negative rad 2 over 2 and rad 2 over 2. And then the last one is 60 degrees away from 180, so that'd be 120. Or 2 pi thirds. And then that point would be negative 1/2 and rad 3 over 2. Okay? And so when we think of reference angles, right, it's just got the same reference angle, but the value of the cosine is negative in the second quadrant. That would also be true for tangent and cotangent and secant as well. They would also all be negative. But if I'm giving advice to people, I would memorize the first quadrant, because if you notice, I got the second quadrant just by flipping the first quadrant in, and I didn't really need to memorize the second quadrant. I just memorized that the x values are negative, but I can still create the second quadrant by knowing the first quadrant. And that's going to be true for the third quadrant. Okay, there's going to be 3 angles, okay, with a reference angle of 30, 45, and 60. And remember, away from this x-axis, sorry I didn't write that point. What would that point be? That would be negative 1, 0, because the radius is 1. And so back to what I was saying, right, 30 degrees away, right, from the x-axis would be 210 degrees. Oops, 210 degrees, or that's 7 pi 6. And what would that point be? Well, think about it. Now we're in the third quadrant, so this guy over here again is now the same reference angle, so 30 degrees, the point is what I'm looking at, but now x and y are going to be negative. So negative rad 3 over 2, comma, negative 1/2. And then we just kind of keep building those points. So that's the point here. The next point is 45 degrees away, so that's 225, or 5 pi 4ths. And so that would be negative rad 2 over 2 and rad 2 over 2. Oops, got to make that negative because they're both negative in the third quadrant. And then the last one being this guy there, and that reference angle is 60, and so you would have that being 240 degrees, or 4 pi thirds. And then that point would just be the 60 degree point, but both negative. So negative 1/2, comma, negative rad 3 over 2. Now I'm going to do this point. This point is 0, negative 1. Whoops. Right, so 0, negative 1, and that is 90 degrees away, so that's 270. And in radians, it's 3 pi halves. Okay, all the way around is 2 pi, or 360, and it would use the same point as 1, 0. And then remember, we're going to have 3 points in the unit circle. Okay, so we'll start with this guy down here. It's 60 degrees away from this x-axis, right? So if you think about it, it's 60 degrees away from 360, so that would be 300 degrees. And I'll put that somewhere else. So 300 degrees, or 5 pi thirds. And the point there would be the 60 degree point, but now notice we're in the fourth quadrant. X values are positive, so 1/2, but the y values are negative, so -3/2. Okay. Next one's 45 degrees away from 360, which would be 315. I'm going to move that again. So 315, or 7 pi fourths, right? It's a fourth away from 2 pi, so 7 pi fourths. And then you would have yourself positive x value, √2/2, and then a negative y value, -√2/2. Last one, 30 degrees away from 360 would be 330, or 11 pi 6, because it's a sixth away from 2 pi, so 12/6 would be 2, right? So that's where it would be. And then positive x value, so rad3/2, and then -1/2. Okay, and ladies and gentlemen, that is the unit circle. So that's the whole thing, right? Couple things about the unit circle. Now that we've drawn the whole thing, there's a couple things that people like to memorize. So things you may remember, you could say all students take calculus. So the all means everything's positive in the first quadrant. S means only sine is positive, and cosecant invariably would also be positive. T, that means only tangent is positive in the third quadrant, right? So tangent and cotangent, it's reciprocal. And then cosine is the only one that's positive in the fourth quadrant, along with secant. So all students take calculus would be one thing that you're going to have to use. And then finally is how would you figure out tangent of theta in the unit circle? Well, to do tangent of theta, there's a couple things, one of two things that you can memorize. It's either tangent in the unit circle is going to be the y value over the x value, right? So you'd have to look at the whole point and do the y value divided by the x value. Or another way of saying it would be sine, since y is related to sine, and then cosine is related to x, so it would be sine divided by cosine. So that's what you need to think about when it comes to tangent, because notice tangent isn't one of the points, right, or isn't one of the values of the point. Tangent is a combination of the two, right? So it's y divided by x. All right, but how do you use this thing that we've got here now that it looks all nice and beautiful and colorful? How do you use it? Honestly, you just kind of got to be good at your math. So if somebody says tangent of 7 pi 6, right, first thing you can do is you can figure out what quadrant are you in. So if you're looking at the unit circle that you've got in your notes, hopefully you took some notes, right? What quadrant are you in? So if I look over here, 7 pi 6 is this guy, and I'm in quadrant 3. So when I think of it, I'm in quadrant 3. Is tangent going to be positive, right? So then the next thing I ask myself, is it plus or minus, right? Positive or negative? So I'm in quadrant 3. Is tangent going to be positive or negative? Well, we just did that thing. All students take calculus. So in the third quadrant, T, right, tangent's positive. So it's going to be positive. And now I need to figure out tangent of 7 pi 6. And as I said before, you want to do y divided by x. So if we go to that point, the y value is -1/2, and the x value is -√3/2. So we're just going to do -1/2 divided by -√3/2. And if you think about it, two negatives make a positive. That's why it's positive. And now we're going to multiply by the reciprocal, so times 2 over √3. That's going to be what we have. And the 2's will cancel out. I'll have -1 over √3, which turns into excuse me, positive. Forgot my negative sign. See, easy to do. So two negatives make a positive, and then I'll just have 1 over root 3, which is root 3 over 3. And so that's all the unit circle is really doing for you. It's not really doing anything else other than what you've already been doing, but most likely it's just a collection of everything we've been doing. And it helps us to kind of like think things through. For me, it's really nice, the visual of seeing where things are positive and negative. So I really like that. So let's try cosecant of 11 pi 6. So we're going to go find 11 pi 6 on the unit circle. That's this guy over here. And cosecant is related to sine, so that's the y value, but it's the reciprocal, so the cosecant of 11 pi 6 is just going to be the reciprocal of negative 1/2, so negative 2. Okay, cool. All right, let's go to secant of pi, right? So give it a shot on your own if you want. Look at your unit circle and see what the, right, we should be looking for the cosine of pi, because then we're going to want to flip it. So the cosine of pi, if you're looking at your unit circle, is negative 1, and the reciprocal of negative 1 is still negative 1. There you go. Right? So you found the x value at pi, it was negative 1, and then you flipped it, still negative 1. All right, negative 5 pi fourths. You might say, hey man, that was not on the unit circle. Maybe, but it kind of is. So I would graph the angle, but graph it right on the unit circle. And essentially what you're going to do is you're going to end up finding a coterminal angle, right? So if you go to negative 5 pi fourths, well, there's negative just means go this direction, so there's negative 4 fourths. Whoops, don't know what happened there. Negative 4 fourths, so there's negative 5 pi fourths would be the same spot as 3 pi fourths. And so now I'm looking for the cosine, so that would be the x value. And as I find it at 3 pi fourths, the same as negative 5 pi fourths, it would be negative root 2 over 2. So this thing would equal negative root 2 over 2. All right, and that's how you build the unit circle. That's how you use it. But if I'm going to give you some tips, I would just memorize the first quadrant. Okay, that's going to be really helpful because that then allows you, right, to build all the other ones. Also, as you become more familiar, start really learning what like sine of 30 is, cosine of 30, and then using that to then find tangents and all that. You really want to memorize it, because if you have to use the unit circle at all times, and you have to draw it, that's fine, but it's always going to take you a couple minutes to build it and then use it. Whereas if you have just the values memorized, then you may be better off. But it's still a really, really good thing to have memorized the unit circle. So my encouragement is memorize the first quadrant and then learn how to build the rest. All right, thanks for joining me. Hopefully that was helpful and it made sense, and good luck to you. All right.